Alright guys, gonna try to record a video on arithmetic series here. Now a series, okay, it says an arithmetic sequence is formed when the same number is added to each term to make the next term. The constant amount being added is called the difference. Remember we did these day 1 of this week. The common difference is found by subtracting any term from the term that follows it. To calculate the nth term, we use this, which was called the explicit formula. Okay. Now, we're going to talk today about arithmetic means, and then we're going to talk about series, which are really sums of sequences. All right. An arithmetic mean are just terms between two consecutive terms in a sequence. So if you said there's 3 arithmetic means between 1 and 9, okay, you would say they're adding something, but you actually are adding it 4 times to get to the 9. It means there's 3 missing terms. So this was if you said 3 arithmetic means between 1 and 9. This one is pretty easy. You could have logicked it out. It goes 1, 3, 5, 7, 9. But we're going to talk about how to find those. Here's just kidding. We'll get to an example. This is find the 38th term. We've been doing this on Monday. So you have a first term of -7. The difference here is they are adding 2. So you would say I need to add 2, 38 minus 1 times, or -7 plus 2 times 37. It's -7 plus 74. I don't know, what is that? -67? Yeah, I think so. No, +67, just kidding. All right, this is where I get my calculator and figure out how much of a mistake I made. -7 plus 2 times 37 is 67. Okay, I got that one. Now, write an arithmetic sequence that has 3 arithmetic means between 3.2 and 4.4. So there's some missing terms in here. But the trick is, if there's 3 missing terms, means they actually added the difference 4 times to get to 4.4. So if we subtract, we're just working backwards. We get 1.2, we divide by 4, and we get 0.3. Then we go back and we find those sequences. We add 0.3, we get 3.5. We add 0.3, we get 3.8. We add 0.3, we get 4.1. We add 0.3, we get 4.5, or 4.4. So this should be self-checking. You should be able to figure out that it worked. Okay. Now, this one says write an arithmetic sequence that has 3 means between 17 and 39. So again, 1, 2, 3, 4 differences were added to get to 39. So if we subtract 17, we get 22. And if we divide by 4, we get 11 halves, or 5.5. So if we add 5.5, we get 22.5. We add 5, we get 7.5, would make that 28. Add 5.5 would be 33.5. Add another 5 would be 8.5, would be 9. So that works. All right. There can be a lot of them. -2, 1, 2, 3, 4, 5, 6, 7, 16. All right, so you would say -2 plus, get in your pen. If there's 7 terms missing, we added the difference 8 times to get to 16. If we add 2 over here, we get 18. We divide by 8. We get let's see, divide those both by 2, and we get 9/4, which is 2.25 if you want to do decimal. So if we add 2.25 to this, we'd get 1/4. If we add 9/4 to that, we'd get 10/4. If we add, you want to do decimals? We can do decimals. I can probably add them better. Otherwise, I think this would be 19/4. Add another 9/4 would be 28/4 would be 7. Add 9/4 would be 36/4. That can't be right. Okay. Should probably start this video over because I've messed up already, but I'm going to just do it as decimals. I don't know where I went wrong there. Probably because I can't add 28 and 9 is 37, not 36. See, I was good until the end. -2 plus 9/4 is 0.25. Plus 2.25 would be 2.5. Plus 2.25 would be 4.75. 7 would be next. Got that one. 9.25, 11.5, and 13.75. A fourth would be 14, 15, 16. So that worked. All right. A series. This is the total point of the lesson today, is that an arithmetic series is the sum of the terms of an arithmetic sequence. You can find a formula to find the sum of a finite, meaning it doesn't go on forever, arithmetic series, or the partial sum of an infinite geometric or arithmetic sequence. So if your sequence looked like this, you could find the sum, right? If your sequence looked like this, you could say, I want the sum of the first 7 terms. Okay? Now, let me show you a little magic here. If I said, what is the sum of the first 100 natural numbers? You could write 1, 2, 3, 4, ... And when you get to the back, you'd have 96, 97, 98, 99, 100. Now, if you wanted to add all those up, look what happens. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. So you would get 101. Now, every 2 numbers added up to 101. There's 100 numbers, so you would get that 50 times. So 50 times 101 is 50/50. So the sum of the first 100 counting numbers, or natural numbers, is 50/50. Now let me show you what that looks like in terms of a formula here. It simply says, anytime you want to add up a sequence of arithmetic terms, you can take the first one and the last one and add them together, and then multiply by the number of terms divided by 2. Okay, that's where that formula comes from. So let's try it on some questions. Find the sum of the first 50 terms here. So they're telling us the first term and the 50th term. That's really nice of them. So you have 11 plus 158 all times 50 over 2 to find the sum of the first 50 terms. I should have written the formula. Okay. So 11, or let's see, 50 divided by 2 is 25. 11 plus 158 is 169 times 25 is 4,225. Sorry about the dogs. I knew the afternoon was not a good time to make a video. Probably the mailman's here. All right. The next one says find the 23rd partial sum. This sounds confusing. It just means that the ... means you're not going to add up every number. You're only going to add up the first 23. Okay. So this means the sum of the first 23 terms. So you're going to have 23 divided by 2 times the first term plus the 23rd term needs to go in here. Well, we know how to find that. This is an arithmetic sequence. So it goes the first term plus the difference and minus 1 times. So the difference here is a negative 11. Is that right? So we have a negative 11. And if we want the 23rd term, we're going to do 23 minus 1 or 22 times in here. So end up with 173 minus 11 times 22. 173 minus 11 times 22 is negative 69, and that's the term that goes in here. So the sum is 173, the first term, plus negative 79, the last term, negative 69, just kidding. And then times 23 divided by 2. So when I type all that in, I get 1196 for the sum of the first 23 terms. All right. I feel like I need to check my key because I'm going to feel really bad if I make a mistake on this video. All right, I'm doing okay so far, I think. Find the 82nd partial sum, so that means the sum of the first 82 terms of this sequence. And it says it's arithmetic, so we can tell the difference is negative 3. So we know the first term, so we're going to add up 82 terms. So we do 82 divided by 2 times the first term plus we need the 82nd term to go down in here. So to find term 82, I take the first term and add the difference 82 minus 1 times. So I have negative 1 plus negative 3 times 81. Negative 244 maybe? Okay. And that's the 82nd term, so that one goes here. Because it says you add the first and last term, which would be negative 245. And then you take the number of terms divided by 2, even if it's a decimal. This one comes out nice. And then you multiply. And I got the sum of the first 82 terms is negative 10045. All right. So this says find the sum of the first 25 terms, and they told us term 1, they told us term 25. So you guys could really do this one. It's just 25 over 2 times 7 plus 79, which is 12.5 times 86. Did I add that right? 7 plus 79 times 12.5. I got 1075. All right. Now this one says find the 53rd partial sum. I'm going to skip this one and let you guys try it. You're going to need to find the 53rd term, and then you're going to need to find the sum of the first 53 terms, okay? So this is an application problem. It says Wakefield Auditorium has 26 rows. The first row has 22 seats. And then the number of seats in each row increases by 4 as you move towards the back. So we have 26, 30, etc. This is term 1, and we're supposed to find the 26th term, or how many seats are in the 26th row. So it's arithmetic. So we're going to take the first term, add 4 seats 25 times, because 26 minus 1. So this would be 122 seats are in the 26th row. And then to find the seating capacity, so we need to find the sum of all the seats. So the sum of these 26 rows is the 26 divided by 2 times the first row and the last row added together. So this is 13 times 144. Is 1872. So the sum of the seats in this 26 row auditorium is 1,872 seats. Pretty easy. So this time we have someone whose first year salary is $64,500, and then the next year they add $3,750. So the second year she makes $68,250. If they added another $3,750, the next year she'd make $72,000. Okay, so what does she make during her 10th year? Well, the first year she made this, but then she got 9 raises of $3,750, or $3,750 is the difference, plus 10 minus 1 is 9. I'm sorry, times 10 minus 1 is 9. $3,750 times 9 plus $64,500 is $98,250 for her 10th year. Now it says, what will her total earnings be for 25 years? Okay, so to find the sum of 25 years, you would need 25 divided by 2, and then the first term and the 25th term needs to go in there. So to find the 25th term, I'm going to say her first year plus $3,750 got added 25 minus 1, or 24 times. So by her 25th year, she was making $154,500. But that's only her 25th year, not all 25 years added together. So if we add that back into the formula, she made $2,737,500 in those 25 years. Okay? And then this is a Delta math question. I just wanted to do one of these. You have to really think about these. It says Hannah gets a box of 100 chocolates for her birthday. She eats 4 chocolates a day starting on her birthday. So while it originally had 100, by the end of the first day, she was down to 96. So the first day ended with 96 left in the box. The second day would end with 92 left in the box. Okay, so this term 100 is what we call a zero term. It's like the initial amount was 100, but after 1 day, she was down to 96. After 2 days, she was down to 92. So what does she have left after 8 days? It's not a sum question. It's really just find the 8th term. So 96 minus 7 more days of 4 going down. Okay, I should have said minus 4 for 7 days, 7 more days. So 96 minus 28 is 68 left. Okay. If we had written it out, we'd take away 4, 4, 4, 4, 4, whoops, and 4. So this are day 1, 2, 3, 4, 5, 6, 7, 8. Okay? You don't need to write them out. I'm just trying to prove to you that you want to call 96 the first term. All right. Last thing real quick is using your calculator. And I don't have mine on yet. You're going to use sum notation. It's called sigma notation. This is a Greek letter sigma, and we put down at the bottom what the variable is and what the starting term is, and at the top you put how many terms you're going to add up. So if I wrote this, it says I'm going to put in the numbers 1 through 10 and add them all up after I put them into this formula. So I put in a 1, I get out a 2, I put in a 2, I put in a 3, I put in a 4, I put in a 5, I'm supposed to go all the way up to 10. So there's the first 10 terms, and now I'm supposed to find the sum. The sigma means I'm finding the sum. So I'd have 22 and 22 and 22 10 times, so I think I get 220, right? If I add the first and last term and multiply by 5, because 10 divided by 2, I get 110. Did I do that right? Let's see. 22, 1, 2, 3, 4, 5 times. Yes, I did that right. Okay. So there's a way to do this on the calculator. Okay, there's 2 ways. One way is to find the sum of a sequence, and then you have to tell it where 2n is the formula, n is the variable, 1 is the first term, 10 is the last term. That looks kind of complicated. I'll show you where those buttons are. It can be useful. It's under list. A sequence, just think of it as a list of numbers. Okay, so we're going to go second stat to get to list. Then what we're going to do is go over to math, choice 5. Okay, so that was under the list button, and we found math. And we're going to pick the sum, number 5. And then we're going to go back under list, and we're going to go to operations, and we're going to say I want to make a sequence, which is choice 5 again. And then it's going to let us type in an expression. If you have an older calculator, it doesn't tell you what these are. You have to try to figure it out. You would put in 2x, comma, right here above the 7 is a comma. We don't have to if you have this system. X, and the starting number was 1, and the ending number was 10 terms. Okay, that's the term number, not the value. And you're counting by ones, which you can leave blank, I believe. Okay, let me go back and you get 110. Let me go back and do it one more time and leave it blank, but I'll show you one more time the buttons. So second stat over to math, choice 5. Second stat over to ops, choice 5. The formula was 2x, the variable was x, terms 1 to 10, and I believe you could just leave this blank. And then hit enter a couple times, and it would give you 110, okay? Now, there's an even easier way. If it's written in that sum notation with that little sigma jobby, it's under the math button. If you scroll all the way down to 0, there's a sum button right there that you can type in. Or I have an even easier shortcut. If you go alpha window, it brings it up right here as choice 2. Okay, and then this is what you get. So even if I had gone through the math and arrowed until I found the one here that says 0, then I still get this little, and I can type in these boxes. If you have an older calculator, you don't get this, and you have to use the way I just showed you with sum, sequence, etc. But if you have this summation symbol, you can just type in these boxes. So I can type an X and a 1, and I can arrow up and put a 10. And then it said 2n was our formula, so 2x goes in here, and it gives me 110. All right, so that was using the actual summation symbol. Okay, in the notes, I'll spread those all out so you can see them. But let's do this problem before we move on. Okay, and I have some notes over here. This one actually starts with term 3. So it's written a little bit different, but this is the same as writing n equals 3 down here, 15 up here, 3n plus 1. So generally, to do this by hand would be a little bit tricky because it doesn't start with the first term. You could write them all out, put in a 3, 4, 5, 6, 7, etc. I'm going to do it the long way the first time, okay? If you have an older calculator, it's second stat over here to choice 5 to find the sum. Second stat over once choice 5 to find the sequence. This time our formula was 3x plus 1 or 3n plus 1. When you put your calculator later in sequence mode, it'll actually give you an n, but it doesn't matter what mode you're in to do this question. X, but we want terms 3 through 15. Yes, 3 through 15. And it will look like that. We hit enter and we get 364. Or you can go again, alpha window, choice 2, X, and we started with 3, not 1, so I want to go over to that box, up to this one and put term 15, and it was 3x plus 1. When you do these, make sure you put everything inside the parentheses they give you. Don't put things outside of those parentheses. Even if you need extra parentheses, keep it inside there. It's especially important with the geometric ones we're going to do later. So get 364 that way for that one. Okay. So this turned out to be, number 9 was 364. And I'm going to move all these down here later so that you can see them, all the little screenshots of everything I did. Okay. Where I found all those buttons. I guess I should have them in order. So if you use the list button, that would be these two. You would go to math to find sum and then ops to find sequence. If you want to use the math button, then you use that summation notation. So that goes with this one. And these go with that. Okay. And then there's 2 more of these, and maybe I'll just do number 11 real quick, and then you can go back and do it. But if you want to go alpha window, choice number 2, and you want to make sure all of this stays inside. It's 1 through 6, so I have 1 and 6 up here. But then in here, I want to put the whole thing. So 3 times 1/2 to the n minus 2. 3 parenthesis 1/2 parenthesis to the, and if you had a really old calculator, you would need n minus 2 in parentheses. But this is all up in the exponent, okay? Or one more time for an older calculator, it would be math, choice 5, back to the list over to ops, choice 5, and you would type, I forgot the formula, 3 times 1/2 to the, now even here I think you're going to need parentheses around the exponent, okay, because it's not in a little box. And then you would say the variable is x. I wanted the sum of the first, and I already forgot, 6 terms. Enter, enter. Enter again, and we get the same thing, 11.8125. Okay, that is an exact answer. You could do a fraction. I think in Delta Math, when you do some of these sums, it asks you to round, so just read carefully what it asks you to round to. Now go back and finish the ones I skipped.